Yes. Hello, 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 hello. Hello, my dear students. So today in this lecture we will be discussing about the Rimmer-Tiemann reaction. So in this particular reaction, थोड़ा हाँ, ठीक है, कोई प्रॉब्लम नहीं. आ रहे हैं यूट्यूब में अभी.
बट एक दिक्कत आ रही है इसमें, ग्रेनी साउंड आ रहा है थोड़ा लास्ट में, झल रेडियो टाइप. हाँ तो वो तो साउंड को एडजस्ट कर दे रहे हैं. चलिए सर स्टार्ट करिए क्लास.
अमर सर को लाइन में रखो ना.
मैंने पूरा अच्छे से तो कर ले, अभी ऑडियो थोड़ा बेकार है, फिर वो बार कमेंट करेंगे, पहले मैं कर रहा हूँ फिर वो करेंगे, पहले जरा सेट कर लेते हैं.
ठीक है अभी हेलो 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 हेलो.
कर दिया आपने ऑडियो का ग्रेनी को?
So there is no problem no regarding the audio. Audio check is fine. Mic testing. Audio check is fine. Check once. Confirm me. Then I will start the class. Okay.
आपने कर दिया है? मेरे में अभी भी आ रहा है.
See here in the studio your sound also both are matching ना. अब ये चल रहे उसका साउंड और मेरा साउंड थोड़ा एको तो रहते ना इसमें.
एको नहीं है सर, ये एको नहीं है, एको का कोई चीज
एक हाँ
एको नहीं है, ये वो है मतलब रेडियो का होता है सर, जैसे रेडियो सुनते हैं तो झल.
अच्छा. సో ఎవరో చూస్తారు लेकिन एक प्रॉब्लम क्या है ना, थोड़ा इधर सब जाए तो आई एम नॉट विजिबल. लेकिन और बड़ा बोर्ड लाएंगे, चाहिए क्या? मेरे को पता नहीं, आप लोग बोले ना 65 इंचेस, उसमें 75 या 75 एक्चुअली कौन सा चाहिए? ठीक है. Hello, hello, hello. Hello, my dear. Can you hear my voice clearly without any issue? There is no problem, right? So you can come here. Is the voice and everything is clear? राजेश जी एक बार कंफर्म कर दीजिए. राजेश जी एक बार कंफर्म कर दीजिए ऑडियो इज कमिंग परफेक्टली और नॉट. सचिन जी आप भी एक बार कंफर्म कर दीजिए. एंड बाबर जी आप भी एक बार कंफर्म कर दीजिए. मेरा वॉइस तो क्लियर आ रही कि नहीं?
लगा दो ना हेडफोन, ये लगा दो ना साउंड बॉक्स. अभी जस्ट टेम्पोररी के लिए ऑडियो क्या मिलता है.
welcome to NSmart. Today we are going to discuss one of the very important concept, one of the very important reaction, that is from aldehydes, ketones and carboxylic acids, that is Remer-Tiemann reaction. This particular reaction is very much important even for board point of view and even JEE and NEET point of view. So let us see. This particular reaction, all we are going to take here phenol. Phenol, whenever it reacts with NaOH or KOH, both you can take any base, NaOH or KOH base. So in the presence of this base and also along with the CHCl3, which is nothing but chloroform, then you are going to get on the ortho position to this phenol. In the ortho position we are going to get CHO group, and along with this one you can also get this particular group, CHO group, at the para position also. So between the ortho and para positions, we know that ortho is major. Ortho is major, right? So this is a very important reaction, and the product which is formed here we call it as a salicylaldehyde. Okay, salicylaldehyde. So this is one important reaction, and along with the reaction here we should also know what is its mechanism also. So let us see its mechanism here. So mechanism of this particular Remer-Tiemann reaction is, so generally this mechanism I can explain in two steps. Step number one is that first of all the phenol which is there, OH, in the presence of sodium hydroxide, phenol will be converted into phenoxide ion, which is nothing but sodium phenoxide, right? And the step number two, along with phenol, and step number two we will be discussing about the attacking reagent. The attacking reagent which is present in this particular Remer-Tiemann reaction, that is chloroform HCCl. This chloroform, first of all it will undergo alpha elimination, where first of all hydrogen will be removed in the presence of OH minus, which came from this particular sodium hydroxide, and Cl, and here you are going to get the negative charge. And alpha elimination means from the same particular carbon, hydrogen and chlorine both will be removed. Then we will call it, then it will be removed by this heterolytic cleavage. Then finally you are going to get one of the reagent important electrophile, which consists of lone pair and also one empty orbital, and a Cl. And what is the name of this particular attacking reagent, students? Very important to be remembered. That is nothing but dichlorocarbene. We call it as a dichlorocarbene. Got the point? Dichlorocarbene. It's very hard, bro. So dichlorocarbene in this one will be the attacking reagent. Chalo, let me erase this particular part here. Once again, let me keep the heading. Remer Tiemann reaction. Remer Tiemann's reaction. एक बार राज जी अब बोलो क्या करेंगे? सब ठीक चल रहे आपकी सबसे? उन लोगों को भी पूछना एक बार. आमा सर को कनेक्ट करेंगे और दिखाएं. है ऑलरेडी? बोलो ना उन लोगों का एक बार. किधर गए? आमा सर को कनेक्ट करने के लिए. मैं फिर एक बार इस बार अच्छे से देता हूँ, इसलिए मैं अभी शुरू नहीं किया, जस्ट ट्रायल कर दिया बस. Where you are going? అది మేము ఇంటికి వెళ్తుర్రా? వా जी बोला? वो बोला कि नहीं? Hello, Sachin sir. Once connect to Ahmad sir and Chandan sir, no? Regarding this one. Ahmad sir, you connect. Ahmad sir को कनेक्ट कर दो, लाइव में देखेगा ना. हेलो हेलो sending this one, okay, to start to Ahmad sir and all. Hello, 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 mic testing. Hello, hello, hello. कर रहे हैं, कॉल कर रहे हैं. ये माइक मिडिल में ऑफ करना बोल तो कर नहीं सकते. क्लोज. ये भी बंद करो. Okay, sound check. 1 2 3. Mic testing. 1 2 3. Is it clear? Mic testing. 1 2 3. Hello, 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 hello. Okay. So, okay. Hello, my dear students. Welcome to NSmart. So, today I am going to explain one of the important reaction, that is Remer-Tiemann reaction. So, this particular reaction, especially we will see in chemical properties of alcohols, phenols, ethers chapter, especially in the chemical properties of phenols. So, let us see what is this particular Remer-Tiemann reaction, and also one more thing, remember that this particular reaction, especially it is very much important in board point of view and even for JEE and NEET point of view. So, everyone should listen to this particular topic clearly. So, in this reaction, in this particular Remer-Tiemann reaction, first of all let me write what is its basic reaction, and also along with that one let me also explain here about its mechanism also. So, why this mechanism is very much important means, here especially we are going to talk about the electrophile. One particular electrophile is going to come as a attacking reagent. So, I am explaining about that particular attacking electrophilic reagent, right. So, let us see the reaction first of all. In this particular reaction, as I said, this is a chemical property of phenol. Here you can see I am taking here phenol. So, benzene ring attached with OH group. So, this is nothing but phenol. This particular phenol, whenever it is going to react with aqueous NaOH, NaOH we can use as a base, or also we can use here KOH also as a base. And along with this, I am also going to add, that is CHCl3, which is nothing but chloroform, right. Whenever we are having these two reaction with the phenol, then we are going to get at the ortho and para position aldehyde group, right. So, aldehyde group will be attached in the ortho and para position. So, this is the phenol, and we know that this is the ortho, meta and para position. So, in ortho position aldehyde group is attached to C double bond OH, and also in para position we are getting OH, and here in para position C double bond OH. Why here ortho and para directing groups you are getting means, ortho and para direction position only CHO group, why it is present means, here phenol is there. Phenol is the ortho and para directing group, and between these two, between this ortho and para groups, ortho will be the major, right. This ortho will be the major. Why it is major? By the end of this particular class you will be understanding, and we call this particular compound which is formed as salicylaldehyde. So, this particular compound we are calling it as salicylaldehyde. Which salicylaldehyde? Ortho salicylaldehyde, and this is a para salicylaldehyde, right. This is the general reaction. This is the general reaction for the Remer-Tiemann's reaction. Okay. So, now how this particular product is formed from this phenol, that we are going to study by understanding its mechanism, right. So, now immediately let us go for its mechanism. So, in this mechanism, especially this mechanism is going to be take place in 3 steps. I am going to explain this particular mechanism in 3 steps. In step number 1, so here I am writing the heading, it is mechanism, and this mechanism step number, this is step number 1. So, in step number 1 what happens? First of all, phenol is going to have OH group, right or not? This OH group immediately it will be having one acid base reaction with NaOH. Acid base reaction means here between O and H bond will be broken, and H will be substituted with what? Sodium. So that we will get O minus Na plus. So O minus Na plus, this particular O minus and Na plus, we are calling it as a what? Phenoxide ion. O minus means, then if sodium is also attached, so sodium phenoxide. So first step we are getting sodium phenoxide, right? After this one, let's go for the step number 2. Step number 2, here actually in this reaction we have to see the electrophile which is adding. That particular electrophile we are going to get from chloroform. One more reagent we have added, no, that is chloroform. From that chloroform, how you are going to get from chloroform, sir? Then let's see here. For example, let me take here chloroform, CHCl3. As you see, C carbon and H, one second, chloroform, C, Cl, 3 chlorines and here one hydrogen, right or not? So from chloroform, first of all, chloroform is not an electrophile. From this chloroform, whenever in the presence of base, see here Na plus goes here, then here we will be having one base, that is OH minus. Whenever in the presence of base, we know that in the presence of base this OH minus will be giving its lone pair to here, so that this particular hydrogen will be removed out in the form of what? H2O. In the form of water, this particular hydrogen will be removed out. Then afterwards, here you can see C negative. One second, see here, and also one more thing, here hydrogen is there. So this bond will be shifted towards this direction. Na? So bond pair is converted into lone pair. So that's why here the negative charge is coming. So here carbon and here Cl, one second, here C minus and here Cl, these 3 Cls will be there. And then next you see, in the presence of this electrophile, one more chlorine also will be removed from here. Chlorine is removed, so that finally we are getting C. Whenever this bond is removed, this negative charge will become what? As a lone pair, and here one more Cl and here one more Cl, and once this bond is removed, then here you are going to get one empty p orbital. Which orbital? One of the empty p orbital here we are getting, right? This point to clear. And sir, you have eliminated this particular parts, it is fine, but tell me which type of reaction or which type of reaction is this one? This particular reaction for a single carbon, for single, this is the alpha carbon, right or not? From this single carbon we have removed both hydrogen as well as chlorine, right or not? So that's why this particular reaction we call it as a elimination reaction. In that particular elimination reaction also, especially we will call it as a alpha elimination. Remember that this is which elimination? Again I am writing here, it is an alpha elimination, alpha elimination reaction. So that here we got one compound. What is that one? One attacking reagent, especially this is an attacking reagent. This attacking reagent, which is nothing but it is an electrophile. Okay, electrophile is the attacking reagent. To this electrophile, here you can see empty orbital is there, right? We also call this particular compound as dichlorocarbene. Okay, this attacking reagent we call it as a dichlorocarbene. Remember clearly, among electrophiles this is also one type of electrophile, like H plus, Cl plus, like that. Okay, this is the step number 2. So we have done with step number 1 and step number 2. Now it is the time for us to collaborate this particular step number 1 and step number 2. Here what I am taking it as a step number 3. Okay, step number 3. So in this particular step number 3, already we know that here we are having phenoxide ion, and this time I am writing one of the resonating structure of this particular benzene, that is O minus, and here O minus is present here, and this one, and here to one hydrogen to already is there. So this one, in the presence of this particular reaction, in the presence of attacking reagent, we know that CCl2 dichlorocarbon is the attacking reagent here. And here especially what happens, why initially I said na, it is an ortho and para directing group. Why we call it as ortho para directing group means here electrophile, this is an electrophile, this electrophile is going to be substituted with this particular benzene. So whenever electrophile is substituted, we know that as here negative charge is there, this bond will be shifting here, so that I am writing here, so that this bond will be shifted here. Here O minus comes this direction, so that here negative charge density will be more here in ortho positions, and here that if you know about the resonating structures clearly, you can answer for this point clearly. So due to this one, here overall you can see that more electron density is present in ortho and para positions, not in meta position, right? Okay, once if you this electrophile is there, let me take here only to get ortho position. This electrophile will be attacked. See here already it consists of pi bond, right or not? This bond will be shifted here, and this particular bond pi bond is going to donate the electrons to this particular electrophile. So that here we can see, again I am taking the same benzene ring, and here this hydrogen though is there like that only, and here naya kya what is added, that is CCl, right, and also here positive, right, CCl positive, and here double bond O is coming here, right or not? So in this way the electrophile has attacked this particular position, ortho position. After this one, let's go for the second step. In this particular second step, here you can see two chlorines are there. So again what I can do, this hydrogen is there, this hydrogen will be removed out, and this bond will be shifted here, this bond will be shifted here, right or not? Here actually it is a negative charge, right? Just okay. So here negative charge is there, and this bond is going to be shifted here in this position, and this bond will be shifted. Why this happens again? Why this bond has to be shifted from this hydrogen to here? Reason is only one reason. What is that reason? Already it is an aromatic compound. You are breaking the aromaticity means again aromaticity will be retained back. Got the point? For that purpose this bond is shifting to this particular position. Then once this bond is shifted, then this hydrogen is there. So this hydrogen want to add in some or other position. You can see here this bond shifted, this bond, so I am writing this particular bond again here in this pi bond, and here O negative, and here C minus is there, here Cl and here Cl, right or not? This is what exactly. And this hydrogen, now it is having two options for this hydrogen, either it should attach to this position or to this particular carbon. So generally we know that nucleophilicity is more for this particular carbon. So that's the reason here you can see the hydrogen is going to attach to this position. So I am erasing again, instead of writing, just I am erasing this particular part, and here I am going to add hydrogen, and here hydrogen is added. Very happy, right? Hydrogen is added in this particular position. Still not completed, just wait. Here you can see, just let me go little up. Okay, this step I will be continuing little next page. In the next page, here you can see so from here O minus though it is there, and at the same time here we got C, H, and this is Cl and this is Cl, right or not? So once here chlorine and here chlorine is present, from here you can see this is an intermediate beta. This is an intermediate. This particular intermediate we call it as a benzal chloride. This is a main intermediate. This intermediate we call it as a benzal chloride. So once this intermediate is done, then here we also know that there are so many OHs are present. Why? Because earlier it is we are making this reaction in particular basic medium only. So OH groups are present here, right or not? So what I will do here, I am writing 2. Why only I am using 2 hydroxides? Why only I am using here 2 hydroxide ions means here you can see the 2 chlorines which are present here. It is going to get substituted. Which type of substitution? Nucleophilic substitution. It is nothing but SN reaction. Which type of SN reaction? As here you can see this carbon is a primary carbon. So primary carbon means we know that primary carbon rate of reaction of SN2 reaction, especially rate of reaction of primary greater than secondary greater than tertiary, right or not? So that's why here 2 times SN2 reactions will be taking place with this particular OH, and finally here you are going to get here O minus, and here you can see C, this H2 will be like that only, and here instead of this Cl 2 OH groups will be attached at this particular position. So here 2 hydroxyl groups are present, and we know that clearly for a single carbon whenever 2 OH groups are present, is that stable? Definitely no. So for a single carbon whenever you see 2 hydrogens are present, then immediately what will be removed out from this one? Water will be removed out, right? In this reaction immediately water will be removed out. So whenever water is removed, minus H2O, water is removed from this particular position. Now you can see here clearly C double bond O H, and here O minus, and also as water is there in the presence of H2O, this bond, what happens? O minus, again hydrogen will be coming and attaching at this particular position, so that OH is present here, right or not? OH is present in this particular position, and here hydroxide group is present, OH, right or not? So finally we got our important product, that is orthosalicylaldehyde. Orthosalicylaldehyde. And remember one more point, initially I said that orthosalicylaldehyde will be the major group. Why it is the major group? Why? Because here you can see the hydrogen here partial negative and partial positive charge is there. So here hydrogen is present and here oxygen is partial negative. So between the hydrogen and oxygen one type of bond is there. What is that bond? It is nothing but intra, not inter, intra, within the molecule, intramolecular H bonding, hydrogen bonding, right or not? So whenever whichever the compounds having the intramolecular hydrogen bonding, it is more stable. Got the point? That's why orthosalicylaldehyde is more stable. So this is what one of the important reactions, my dear students, to know about. And once again I am telling, this is very important topic, and definitely each and every one student, especially for board I am telling. See, for JEE and NEET though, from where the questions will come we will not have exact idea, but this particular question is very much important for board point of view. So इसमें ध्यान रखना है सब लोग, और everyone should follow this particular in the same way. Okay, so this is what I want to explain about today's topic, my dear students, that is Reamer-Tiemann reaction. So thank you very much for being here and listening to my class. And also I want to tell one more thing, all the best for your coming JEE examination. All the best for your JEE upcoming 2026 JEE session.